Good morning, grade 8s. Mr. Kabalka here. I just wanted to demonstrate one of the properties of light, namely the reflection of it when it hits a plane surface, a plane reflective surface. Plane basically just means flat, straight surface. Like this mirror over here is a plane surface. I'm going to place this mirror on this line over here. That's the one item we're going to need. The second item we're going to need is a ray box. A ray box is basically a light inside a box which then shines through this little slit over here onto that plane surface. Okay, so I'll switch it on and there we have the situation. So I'm angling it so that the light hits the plane surface at a particular angle, and as you can see, the light ray is then reflected off that surface. If I take this away, you'll see the light ray just goes straight through, and once I place the reflective surface on there, the light bounces off it and goes in that direction. Now the light ray coming from the ray box to the plane surface, that is called the incident ray. Okay, and the light ray that bounces off that is called the reflected ray. So I'm going to mark these points for you quickly. So the light hits approximately there. Oops, sorry. Okay, so the incident ray is over here. I'm going to complete this drawing now, and then the reflected ray goes off on that direction. I'll just mark it over there. Okay, so let me just do this as accurately as I possibly can. Let's get this as accurate as possible. Okay, let me just see the light ray coming from the ray box there and there, and then the light ray that has been reflected off the plane surface there. Then we're going to complete the drawing, and then we are going to label the parts, and we are going to take some measurements. So let's mark off the points. We have our incident beam, our incident ray coming in there. I'll put a little arrow on it to indicate the direction. And then I have our reflected beam over here, like that, coming off over there. Okay. I'll mark the incident ray, I'll call it AB, AB, and the reflected ray I'll call BC. Okay, now what we need to do is, we need to measure the angle of the incident ray. So how do we measure that angle? Well, for that we are going to need a protractor. Now I had a protractor here. So I'm going to measure an angle between the plane surface over here, so I'll just label that as my plane surface. I'm going to measure an angle of 90 degrees between my plane surface, okay, and a line which I'm going to draw at 90 degrees to it. That line at 90 degrees to the plane surface is called the normal, okay, and at that point, so I'm going to see, let me just check, eyesight's going a little bit here, let's see. And there's the 90-degree mark. Okay, it's a pity I don't have a different color pen, but that's fine. So that's what we're going to do as accurately as we possibly can. Here we go. And this is going to be called the normal. Okay, so the angle of incidence is the angle between the incident ray and the normal. In other words, it is this angle over here. Okay, we are going to measure the angle of incidence. Let me just quickly check my notes. These notes, by the way, is all on page 8 of the notes. Okay, so we've got the angle of incidence and then the angle of reflection. Let me just quickly see. Measure angle ABD. Let's see. Angle ABD, angle of incidence. So let's make that D over there. So this is going to be my angle of incidence. Angle of incidence. And then the angle between the normal and the reflected beam, that is called the angle of reflection. Okay, so that is my angle of reflection. So I'm going to give you a copy of this, and what you then have to do is use your protractor and tell me the size of this angle and tell me the size of that angle. In other words, give me the value for the angle of incidence and the value for the angle of reflection in degrees, and tell me if you notice anything about those two angles. And that piece basically will conclude one of the first laws of reflection, and that's the end of this demonstration. Thank you.